All right, you guys, for the last couple of videos, we've been solving quadratics by factoring. Now let's take that principle and apply it to some word problems or application problems. All right, so let's read our first one. So it says solve by factoring. The area of a rectangular poster in the atrium of Building 1 of the Osceola campus is 36 inches squared. The length of the poster is 5 inches more than the width. What are the length and width of the poster? Okay. So let's go through and highlight the information that's important to us, okay? So the first thing is we are dealing with a rectangular poster, okay? And they also told us that the area of the poster, okay, is 36 inches squared, okay? The other thing that we know is that the length of the poster is 5 inches more than the width, okay? And the question they are asking us to find, all right, are what are the length and width of the poster, okay? So let's see if we can kind of sketch out what they gave us so we have a better vision of what to do. So we have this poster, that's a rectangle, okay? And what we know about a rectangle are that opposite sides are equivalent, okay? We also know that we have the area. So anytime we have the area of a rectangle, the way that we find that is length times width. Okay, and we know that the area of this poster is 36. Okay, the other thing that we know is that the length of the poster is 5 inches more than the width. So they told us that the length is 5 more than, that means addition, the width. Okay, so that means in my equation, everywhere that I see length, I can replace it with 5 plus w. Okay, so on our picture, I could write this as 5 plus w for the length on this side, 5 plus w with width. So in my equation, I'm going to replace L with 5 plus w times w. Okay. Now let's try to solve this. So the first thing we should do is distribute this w to both of our terms in the parentheses. So that's going to give me 36 equals 5w plus w squared. Okay. Now, once I see this second power here, okay, this lets me know that I have a quadratic, okay? So we're going to follow the same steps that we did before in factoring our quadratics. So the first thing we're going to do is set our equation equal to 0. So I'm going to move this 36 to the right side, okay? And I'm going to put my terms in descending order. So that means from highest power to lowest. So my w squared is going to go first, plus 5w, and then minus this 36. I move from the other side, okay? Now that I've done that, I see that I have a trinomial whose leading coefficient is 1, okay? So I'm looking for factors of 36 that are going to give me the middle term, which is 5. So if I list the factors of 36, that gives me 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So of those pairs, the one that's going to give me a 5 is the 4 and the 9. And I need a positive 5. So that means the sign on my 9 is going to be positive and the sign on my 4 is going to be negative. And I'm going to take those factors and completely factor my quadratic. So I'm going to do 2 sets of parentheses. The w is going to go in the front of each of them because that's my variable. And minus 4 will go in one, plus 9 will go in the other. Okay. Our steps say once we factor it, we need to set each one of our factors equal to 0. So I'm going to have w minus 4 equals 0 and w plus 9 equals 0. And then I'm going to solve for w. So on the first one, I'm going to add 4. So w equals 4. And the second one, I'm going to subtract 9. So w equals negative 9. Okay. Now, we've been solving quadratics. But now, because this is in the context of a word problem, the answers that we give have to make sense in the context of the problem, okay? So remember, for us, W represents a width, okay? So width can't be negative. We don't take measurements using negative numbers. So W equals negative 9, that's out, okay? So our W is 4, okay? But remember, they want us to find the length and the width. So we just found the width. So in order to find the length, we can plug W equals 4 into our equation for length. So that means L equals 5 plus 4, which equals 9. Okay. So if they ask us for our dimensions, well, our length we just found is 9 inches, and our width is 4 inches. So we have a 9 by 4 poster. So just be careful. The math is all right, but just make sure that your answers make sense in the context of your problem. Okay? All right, let's try another application problem. Let's try this one. So same directions, it says to solve by factoring, but this time our prompt says, Oliver wants to sell college textbooks. The revenue function is given by R of P equals negative 10P squared plus 2000P, where R of P is the revenue and P is the price in dollars. At what price will the revenue be zero, or at what price will Oliver make no money? Okay, so let's highlight the important information in our problem. So our revenue function is R of P equals negative 10P squared plus 2000P. And the question that they want us to answer is at what price will the revenue be zero, or at what price will Oliver make no money? Okay. Well, if revenue equals zero, or he makes no money, we're going to set our function equal to zero. So we're going to have 0 equals negative 10P squared plus 2000P. Okay. This is a quadratic function. I know this because of the second degree power. Okay. So that means I'm going to try to solve it by factoring. So the first step, remember, is to set your equation equal to 0. It is. The next thing I'm going to do is I'm going to factor it. So I'm going to check to see if there's a GCF, or greatest common factor. There happens to be one. The GCF is negative 10P. So if I factor that out from both of my terms, that's going to leave me with P minus 200. Okay. All right. Now I can set each one of my factors equal to 0. And I'm going to solve for P. So in the first one, I'm going to divide both sides by negative 10. So P equals 0. And for the second one, I'm going to add 200 to both sides. So P equals 200. Okay. So there's actually two prices at which Oliver can charge and make no money. He can either charge 0, which means that he gives the books away for free, or he could charge $200 and make no money. So what it probably means that when Oliver charges $200 per textbook, it probably means that he bought each textbook at $200. So if he sells it for $200, he will break even. He won't make any extra money. So he can either sell them for free, or he can sell them for the price that he bought them for, which both result in him making no revenue. Okay, I hope this helps.